The same thing happens with Gigabit Ethernet 802.3z, or 1000 base T, which defines a bus topology, still has half or full duplex operation, and still runs on 1000 base T category 5 unshielded twisted pair cable at 100 meters. We can still run Gigabit Ethernet over the same cabling on which we ran 10 megabit Ethernet as long as it meets the category 5 standards. These categories typically indicate the number of twists on each pair of cable per inch, possibly the thickness of the sheath that the cable is in. Category 5E cable actually has a nylon thread that runs through the unshielded pairs and takes away some of the crosstalk and the attenuation on those pairs, and that gives it the capability of gigabit speeds. But most of our organizations that are going to use gigabit are using some form of optic fiber, and we actually have two different types of optic fiber that can be used. One is called the shortwave, and the other is called the long wave. Shortwave multi-mode fiber can take me up to 260 meters. 1000 base single mode fiber, or the long wave, can take me all the way up to 10 kilometers with a raw transmission rate of 1 gigabit per second. Notice what's happened here. Aggregate rates still double and are full duplex. By the way, Gigabit Ethernet is almost always full duplex. But take a look at an 8-bit data path at 125 megahertz. Looking back, when was the last time you dealt with a PC that had an 8-bit data path? We have been in 32-bit processing now since the 80s. What we're talking about still has a lot of room for growth. Now we're dealing with 3 gigahertz in the number of cycles per second, but we definitely can improve upon even this standard in the future.